And we're going to finish up 7.3, so I'll call this 7.3b. And it's more the same thing, just showing you how the problem gets a little bit more complicated. As I mentioned in the first video, that we have multiplication. Well, you can move the term that includes y to the other side by multiplying by the reciprocal. I mentioned that in the first video. And every year that I do this, somebody struggles, so don't be afraid, to ask questions. I don't want to over-explain it, but maybe you think about to move the y term to the left side is to divide it over. Well, it's got to be divided by something. So 1 divided by y minus 2. And in a similar manner, we want to leave x to the fourth over here because that's your x term. So multiply dx to the right side. So now we're able to do the integral on both sides. Now on the left side, notice that y minus 2 is in the denominator. And it's been a while since we've done this, but the integral of that is natural log of that quantity of y minus 2. You could do u substitution on this, but I hope throughout this unit you recognize that if it's just y to the first power, it's technically this. If you did u substitution and let the denominator equal y minus 2, you would figure out that the numerator's derivative is 1. So that does work that way. Anyway, over here is pretty straightforward. You add 1 to the exponent, multiply by the reciprocal. And this is where you want to write your plus c. You do not need to write your plus c on this side. I think I forgot to mention it, but notice that I wrote the absolute value in here because we can only log positive numbers. So that might be a big deal as we do this. But anyway, I think we are ready to do the initial condition, which is basically plugging in 0 for x. Well, 0 to any power is going to be 0, so you just have c on the right side. And then on the left side, you can plug 0 in for y, and 0 minus 2 is negative 2, but when you do the absolute value of that, you get positive 2. So now when I replace this c with natural log of 2, remember the whole goal is to get y by itself. So what we have is natural log of y minus 2 is equal to 1/5 x to the 5th plus natural log of 2. You may have forgotten because it's been a while. To undo natural log would be to take the e to the other side. If you notice, I'm dropping the absolute value because an exponential function is always positive. It doesn't matter what you have for x, because when you do an exponential function, you'll get the positive. And then how I'm going to leave my answer is I'm just going to write 2 in front. 2 plus e to the 1/5 x to the 5th plus natural log of 2. I believe that's all we need to do in this problem. Let's move over to the answer key just to sort of confirm. His work might explain a little bit better as to why we write it as 1 over y minus 2. Yeah. I guess he waited until the very end. Well, I'm glad we're going back to the answer key because I guess I just dropped the absolute value right away. And one more thing that he did is he split up. I didn't even think about doing this. But we do need to practice some of the rules of exponents because, again, multiple choice can be written in multiple different ways. So I'm going to explain this, and then I'll talk about why we have a plus or minus. So let's go back to those notes. And let me take away this step real quick and explain what he did. Is if you are adding in your exponents, like we do here, you can actually rewrite that as splitting up the exponents with multiplication. And if you're confused by this, I would just suggest, okay, well, if we had this piece and we're multiplying with the same base, what do you do with the exponents? Oh yeah, we add them together. And the reason why this is what he did is because e to the natural log will cancel each other out, as we mentioned before. So what we're looking at is, 2, he just moves that 2 in front. E to the 1/5 x to the 5th power. Now, why should I have left this as an absolute value and a plus or a minus? And we kind of examined it earlier, is when we plugged in 0 for y, we had the negative version of that answer. So that's why I should have left it as plus or minus. And so when you solve for y and add 2 over, now only one of these answers is correct. And that's where he went earlier and plugged in back to the initial condition that when x was 0, you get y is 0. Well, if x is 0 here, the only way to get it to be y is 0 is if this is 2 minus 2, because 2 plus 2 would give you 4, and that's not the right answer. So that's why I should have left this as absolute value and left this as plus or minus. The option that we want is the minus in order to get y equals 0. There we go. Moving on to the next problem, I would argue is just as difficult as the previous one. I hope you're not thinking that. It's going to take practice, but you can notice that I'm dividing y minus 1 to the left side, dy, and on the right side, that 1 over x squared stays there, but it makes more sense to write as x to the negative 2nd power. Because if you left it as 1 over x squared, I can imagine already somebody will want to do natural log of that answer. But that's not correct. Okay, so the left side is natural log of y minus 1. But on the right side, remember, you add 1 to your exponent and you divide by your new exponent. And then plus c. So now we're ready for that initial condition. When x is 2, we get 0. So we're looking at natural log of negative 1 is equal to, well, 2 to the negative 1st power means 1/2. So we're looking at negative 1/2 plus c. And they do expect you to know that the natural log of 1 is equal to 0. So if you solve for c, you just have 0 and add 1 to the left side, it's 1/2. So as I go back to the c value and I plug it back in, I'm going to switch back to red, I have natural log of y minus 1 is equal to negative 1 over x plus 1/2. So then we can take e to that side. I'm not going to make the same mistake. So e to the negative 1 over x plus 1/2, which again, you could split up. The only thing is I don't really see a benefit of splitting that up. So just like before, it would be plus or minus that value. And when you're solving for y, you're going to add 1 over. And remember, we want when x is 2, we want a y value of 0. So which, is it plus or is it minus to do this? And you can guess. I mean, there's nothing wrong with guessing. When x is 2, we need a y value of 0. Is it plus or is it minus? Well, negative 1/2 plus 1/2 is 0. E to the 0 power is equal to 1, and 1 minus 1 would give me 0. So the answer that we want is y equals 1 minus negative 1 over x plus 1/2. And again, you may want to practice some of the simplification techniques that we've talked about. I'll show you the answer key, see how he left it as this. But there's other ways of writing the same answer. And it's up to you, ultimately. He even shows an extra step right here, which I kind of like. With a lot of practice, though, you won't need all of those steps. All right. And then in the notes, I also have a 2000 question. This is before I took the AP test. But you can see it's only a two-parter. And I would argue that they will not ask you a question like Part B anymore. They stopped asking about domain and range in problems like this. So the main thing is, can you do a problem like letter A? And the very first thing is make sure you do your separation of variables. 3x squared dx. So that'll get you a point. Integrate both sides. Now, you can do u substitution on this, but remember this is the chain rule. So if I asked you the derivative of e to the 2y to give you e to the 2y, you'd also have to multiply by the derivative of the numerator because of the chain rule. So it makes sense to divide by that. And in this one, add 1 to your exponent, divide by your new exponent, plus c. So again, this should get you 2 points. So a point up here, a second point, and a third point for the correct antiderivatives. Then from here, use the initial condition. So 0 for x, well 0 cubed is going to be 0. And then 1/2 in for y, well half of 2 would be 1. Well, you don't have to write e to the first power. So there's your fourth point. You already found what c is. But notice the directions. They want you to solve the equation for y. Well, how do I do that? That's going back to this problem and saying, okay, 1/2 e to the 2y is equal to x cubed plus 1/2 e. Well, let's multiply everything by 2 to get rid of that 1/2. 2x cubed plus e. Let's get rid of the e by natural log both sides. So we're looking at just 2y is equal to the natural log of 2x cubed plus e. And then divide everything by 2. Or you can multiply by 1/2. Now, as far as the directions go, we have the initial condition that when x is 0, we get 1/2. Well, let's talk about that real quick. If I plug 0 in for x, we get a value that works. So the whole point of this and why they have a part B to the problem, and I think they would not ask for the domain and range on a test like this. But we can only log positive numbers. So let me just jump to the answer key because I do have this answer. Is he talks about how we can only log positive numbers. So I did not get e to the 1/2 though. Oh, because he changed the problem around. Okay. That was very confusing. But notice what he did is he just set the log greater than 0. And then I'm not sure how familiar you guys are. It's been a while since we've done logs. But the range of logs is -infinity to infinity. So I'm not going to stress about domain and range. Is that I have not seen that as a question. 2000 was what, 20 several years ago. I don't think they would ask you. I would consider that a pre-calculus question. There's enough content in calculus that they will not ask about domain and range. But that's the main idea with that. So I'm not going to stress out about that part. And you should be ready for the homework. Feel free to Google if you need any guidance. Notice that we can also ask you for the second derivative. So if you need some guidance there, and everything's coming together. And then we'll be ready for slope fields in the next video.